Good day, viewers all over the world. You are welcome to Troy online class. Today, we want to look at triple angle formula. So, you will recall that the fundamental identity is sine square A plus cos square A is equal to 1, where A is the angle under consideration. So, when we discuss about double angle formula, you recall that sine 2A is given as 2 sine A cos A. Then cos 2A is given as cos square A minus sine square A. And or is given as 1 minus 2 sine square A. These are the derivation, or 2 cos square A minus 1. So cos 2A has three different derivation. Then tan 2A is given as 2 tan A all over 1 minus tan square A. So these are the formulas that we have under double angle. That is sine 2A, cos 2A, and tan 2A. So today we want to look at triple. That is sine 3A, cos 3A, and tan 3A. So what are we going to get when we have triple angle? So that is what we are about to discuss. Triple angle. So we start with the sine 3A. We can divide it into sine 2A plus A. That is 2A plus A, of course, will give us 3A. So that when we express this, we have sine 2A cos A plus cos 2A sine A. Of course, since this is sine, we can actually rewrite this in form of, we rewrite everything in form of sine. So that sine 2A is 2 sine A cos A, then multiply by cos A plus cos 2A. Let's write cos 2A in form of sine. That is the derivation in form of sine. It will be 1 minus 2 sine square A all over sine A. That's what we get. That if we expand this, we are going to have 2 sine A cos square A plus sine A. Sine A will do this. Then minus 2 sine cube A. That's what we are going to get when we expand. Of course, from fundamental identity, cos square A, sine square A plus cos square A is equal to 1. So if I make cos square A the subject of formula, I'm going to get cos square A to be equal to 1 minus sine square A. So from there, I will have 2 sine A into bracket, instead of cos 2A now, I'll change it to 1 minus sine square A from the fundamental identity, then plus sine A minus 2 sine cube A. Then if I open up, I'm going to get 2 sine A, 2 sine A minus 2 sine square A plus sine A minus 2 sine cube A. No, this will be cube because sine square times sine, that's sine cube. Then finally, sine 3A is given as 2 plus sine A, 2A plus sine A, that will be 3 sine A minus 2 minus 2, that's minus 4 sine cube A. So this is the expression for sine 3A in terms of sine. So this will be the expression for sine 3A in terms of sine. So if you are given the triple angle sine 3A, the expression will be 3 sine A minus 4 sine cube A. So irrespective of what you are given, once you know this formula, you should be able to apply it to any given problem. So that is that about sine A, sine 3A. Then we talk about cos 3A. Of course, under cos 3A will be cos 2A plus A. So this will be cos, then we have cos 2A cos A. When we have plus, it is negative, minus sine 2A sine A. That's what you get. That's what we are going to get. Then if you expand this, cos 2A, this is cos now. So we are going to rewrite this in form of cos. Cos 2A can be given as 2 cos square A minus 1. That will be the expression for cos. Then minus Sine 2a is 2 sine a cos a. Then everything multiplied by sine a. So once you follow the steps, and based on the last video, you should be able to express all this. Then from there, I'm going to have 2 cos cube a minus cos a, then minus 2 sine square a cos a. That's what you are going to get. Then what is sine square a? From fundamental identity, we can expand further. Minus cos a minus, let me bring out 2a, 2 cos a. Then sine square a is going to give me 1 minus cos square a using fundamental identity. So from there now, I'm going to have 2 cos square a minus cos a, then minus 2 cos a, minus is plus 2 cos cube a. This cos cube a, cos cube. Then from here, we realize that cos 3a will now be 2 cos cube a plus 2. That will be 4 cos cube a. Then minus cos a minus 2a minus 3 cos a. So this will be the expression for cos 3a in terms of cos. So we've gotten the expression for sine 3a. This will be the expression for cos 3a in terms of cos. Then that of tan also is the same process. Is the same process. Is the same process. That's right. Tan 3a. You divide it. You have tan 2a plus a. Then when you follow the step, we are going to derive what I'm about to write now. So it's the same process. It's the same process. So for tan 3a, it's still the same thing. When you follow the step, we are going to get for tan 3a, it will be tan 2a plus a. And of course, what is the expression for tan 2a plus a? This will be tan 2a plus tan a all over 1 minus tan 2a tan a. Okay. Then what is tan 2a? We know the expression for tan 2a. Tan 2a has its own expression. Tan 2a is 2 tan a all over 1 minus tan square a plus tan a all over 1. That's for the numerator. Then the denominator, we have 1 minus tan 2a is 2 tan a all over 1 minus tan square a. Everything multiplied by tan a. Then if you consider the numerator now, the LCM will be 1 minus tan square a. Okay. So we are going to have 2a, 2 tan a plus 1 in this. Then that will be tan a multiplying 1 minus tan square a. This is what we have for the numerator. Then divided by the denominator now, we are going to have the LCM will be 1 minus tan square a. This will give us 1 minus tan square a minus, that will be minus 2 tan square a. That is what we are going to have. So from this point now, under trigonometry identity, you should be able to prove any formula as long as you follow the step. A, I'm going to have 2 tan a. I'm going to have 2 tan, in this place now, I'm going to have 2 tan a. When I open up, I will have plus tan a here. I'm going to have plus tan a here. So at the numerator, I'm going to have 3 tan a, 2 tan a plus, that's 3 tan a, minus, so minus tan cube a. That's what the numerator will give me. All over 1 minus tan square a. Then, if I want to change division to multiplication, that will be the reciprocal. So I will have multiplied by 1 minus tan square a all over. I will not bring the numerator here. I have 1 minus tan square. This minus tan square a minus 2 tan square. That will be 1 minus. That will be 1 minus 3 tan square a. So this will take care of this. At the end of the day, tan 3a will be given as 3 tan a minus tan cube a all over 1 minus 3 tan square a. So this will be the expression for tan 3a. So this will be the expression for tan 3a. So we have been able to show the expression for sine 3a. We have been able to show the expression for sine 3a. We have been able to show the expression for cos 3a. Then we have also been able to show the expression for tan 3a as we have it on the board. So you should know that under multiple angle, we can find anything. As long as you know the fundamental identity and you follow the steps, you should be able to expand. You should be able to solve any given problem. So these are the expression for multiple angle. And please note, we can also generate expression for sine 4a. Sine 4a. You can do that of cos 4a. You can do for tan 4a. You can even do for sine 5a, and in that order. So the general concept here is called the multiple angle formula. So it could be double, triple, maybe 4, 5, 6, and what have you. So once you follow the step, you should be able to generate all this under multiple angles. So we have been able to generate the value for 3a, cos 3a, and tan 3a. So you can be asked to give an expression to expand something. For instance, there's a particular question here that says that we are given sine. Of course, in this question now, what we are asked to do, we've done it before. But let me just introduce the question. Example. The question says use the formula. Which formula? Sine A plus B. Of course, we know this to be sine A cos B plus cos A sine B. This is what we are given. Then cos A plus B to be equal to cos B minus sine A sine B. We have to use this formula to show that, what do you want to show? The first one, to show that tan A plus B is equal to tan A plus tan B all over 1 minus tan A tan B. Of course, we didn't show this. I only made the statement when we discussed it. We did not show it. The second one is that we should also show that tan 2A is equal to 2 tan A. We have shown this all over 1 minus all over cos A minus tan A. Look at what we are asked to show. Tan 2A is equal to, this is cot A minus tan A. Then the last question, C, we have to find sine 3A to be equal to 3 sine A minus 4 sine cube A. So we are not going to do this. This C, the C part of the question, we are not going to solve this because we have just solved this. I've shown us this morning, this in this class. So we are not going to do this. Then the last one, the question says if tan A plus B is equal to 1 over 7 and tan A is equal to 1 all over 3. So find tan B. So this is the question. We are given sine A. But we are going to shoot every other question. So how do we solve this solution? The first one, we have to show that tan A plus B. We have to show that tan A plus B. What is tan A plus B? Tan A plus B will be Tan is equal to sine all over cos. It will be sine A plus B all over cos A plus B. This is the expression for this. And sine A plus B, we have it to be sine A cos B plus cos A sine B. Then all over cos A plus B is cos A cos B minus sine A sine B. So we are given all this. We are given this. So this was at this point now, since tan is sine all over cos, we are going to divide both the numerator. We divide through both the numerator and denominator by cos A cos B. We are going to use cos A cos B to divide everything. That is, we are going to have sine A cos B all over cos A cos B, then plus cos A sine B all over cos A cos B, then all over, this is the division line. We have cos A cos B divided by cos A cos B, then minus sine A sine B all over cos A cos B. This is what we are going to have. So if you do that, you realize that some of these things, some of these concepts will cancel out. Cos B will cancel cos B, cos A will cancel cos A. Everything here will cancel everything here. Then yeah, okay. Finally, we are going to have sine A all over cos A, which is equal to tan A, plus sine B all over cos B, which is equal to tan B, all over, this is 1 here, minus tan A tan B. And that is what we are asked to show. And that's what we have shown. We have been able to show that tan A plus B is equal to the expression at the right hand side. So that's what we are asked to do. So we are done with the first one. So we go to the second question, B, the B part of the question. So we are asked to show that tan 2A is equal to 2 tan A all over 1 minus over cot A minus tan A. So in this case now, this is double angle. If from the A part of the question, if we put B equal to A, if we say B equal to A, we are going to have A plus A, that will be 2A. 2A. What will be the expression for 2A? It will be tan A plus, instead of tan B now, we change it to tan A because we have assumed B to be equal to A. It will be tan A all over 1 minus tan A tan A. That's what we are going to get from there. So if that is the expression, then we can continue from there. So from here now, tan A plus tan A will give us 2 tan A. Then all over 1 minus tan square A. So that is what we are going to have. 2 tan A. But if we look at this denominator, if you look at the denominator, we can actually divide. If we decide to divide the denominator by tan A, that is, we are asked to show, we want to show that tan 2A is equal to 2 tan A all over cot A minus tan A. So if we divide this denominator 2 tan A, let's divide the denominator. Let's divide it through by tan. Divide by tan A minus tan square A divided by tan A. Tan, we cancel one of this tan. Then at the end of the day, we are going to have 2 tan A to be equal to 1 all over tan is cot. It will equal to cot A minus tan A. And that is what we are asked to show. We are asked to show that tan 2A is equal to this. So this is what we are asked to show, and we have been able to show that. So we now go to the third one, the D part of the question. I said we are not going to do the C part of the question because we have shown that today. So given that tan A plus B is equal to 1 all over 7 and tan A is equal to 1 all over 3, we want to find tan B. Tan B is unknown. So from the first expression that we derived, we are able to show that tan A plus B is equal to tan A plus tan B all over 1 minus tan A tan B. So this is the expression. So tan A plus B is given as 1 all over 7. This is right hand side. Then tan A is equal to 1 all over 3 multiplied by tan B. We are looking for tan B, is the unknown. All over 1 minus 1 all over 3 tan B. This is what we have. Then if this is the case, this simply means that this will give us tan B all over 3 at the numerator. If I find the LCM at the denominator, the LCM will be 3 divided by 3 minus tan B. That's what you get. So from there now, if we cross multiply, from there, we can cross multiply. We can do cross multiplication. If we cross multiply from there, or let me just rewrite this, 1 all over 7 is equal to tan B all over 3 divided, that will be multiplied by 3 all over 3 minus tan B. From here, this is what we get. This will cancel this. So that at the end of the day, we are going to have 1 all over 7 to be equal to tan B all over 3 minus tan B. This is what we are going to get. So at this stage now, I can do cross multiplication. I can cross multiply. So if I do that, I'm going to have, if I cross multiply, I'm going to have, if I do that, I'm going to have 1 all over 7. Tan A plus, no, I think something is wrong somewhere. Let me rewrite. When I have tan A plus B to be equal to tan A plus tan B all over 1 minus tan A tan B. This is 1 all over 7. We are given as this. Tan A is 1 over 3 multiplied by tan B all over 1 minus 1 all over 3 tan B. And this is going to give us, no, this is plus tan B. Is plus tan B. So when we find the LCM at the numerator, I will have it to be 3. So I'm going to have 1 minus 3 tan B. That's what I'm going to get. Then divided by, at the denominator, if you find the LCM, it is 3. So that will be 3 minus tan B. That's what we are going to get. So 1 all over 7 will now be equal to 1 plus 3 tan B over 3 multiplied by 3 all over 3 minus tan B. That's what we are going to get. 3 will take care of 3. So we have 1 all over 7 to be equal to 1 plus 3 tan B. I made a mistake the other time. All over 3 minus tan B. So this is what we get. So from here now, if we cross multiply, I'm going to get 7 multiplied by 1 plus 3 tan B to be equal to 3 minus tan B. So if I open up, I have 7 plus 21 tan B to be equal to 3 minus tan B. So that's what I'm going to get. Then I collect the like times. 21 tan B plus tan B is equal to 3 minus 7. That will be 3 minus 7. So it's equal to 3 minus 7. Then 22 tan B will be equal to minus 4. We divide both sides by 22. So tan B will be equal to minus 4 all over 22. So finally, the value of tan B will now be equal to minus 2 all over 11. And that will be the final answer to tan B. And that is what we are asked to find. So I would love to stop here because of our time. In our next class, we are going to continue from here. As I've said earlier on, apart from the double and multiple angle, we can also generate the value for cos A, cos 4A. We can generate values for sin 4A. If we can even do that tan 4A, and in that order, we can generate value for sin 5A, cos 5A, tan 5A. So in the general concept, it is called the multiple angles. So we can you actually generate value for all these values. Thank you.